Okay, dear students, welcome to this new video. And in this video, we are going to learn about banking of the roads. Now, what is this banking of roads? You might have seen this thing sometime that there are some roads which are inclined like this. Like the road is inclined here and the car is literally turning. It is not flat now. So the road is not flat on which you are moving. Instead, it is like this. So it is going like this. So why is this done? And some other examples we can take. Have you ever played with Hot Wheels? And those cars, they were like the turning was happening by itself when the track was bending like this. So the turning, like the car is coming from a higher land and it is gaining the kinetic energy, and after that there is a turning. It turns automatically without skidding. And that is facilitated by turning the road a bit like this. This phenomena is known as banking of the roads. Now the question is, why are we doing this banking of the roads, and what is the mathematics behind it? What is the role the friction is playing in this? Why do we need banking of the roads? Let us try to understand that now. Okay, so first of all, when we are trying to negotiate a turn, in those kind of cases there can be three cases that we have to study. The point number one is when there is only friction and there is no banking, only friction between the tires and the road, but there is no banking of the road and the car is negotiating a turn. Point number two, there is no friction and only banking. And only banking is there. And point number three is when both of them are there, like friction is there as well as the banking is there, which is usually the practical case. And here both friction and banking are present there. Now this is like, these are the three cases that we are going to study to absolutely understand like what is this topic, and you would be in a position to answer everything. Let us go to the first case when there is only friction here. So what is happening, you see, like this is a flat surface. Now there is a vehicle here. Not that very good at drawing, but still let me try my hand. Like this. So this is the car which is trying to negotiate the turn. And I told you in the circular motion, horizontal circles, we did that. Whenever a body is moving in a circular fashion, it needs some or the other force to act like centripetal. Otherwise, it cannot move in a circular fashion. So if you have to negotiate this turn, some force has to act like centripetal. Now, what will be that force? In such cases, there is only friction. This is case number one, only friction and no banking. So frictional force will be providing the required centripetal force. How? Um, See, there are two ways in which the vehicle is going. First of all, like let's say this is the car. I'm watching it from the top now, and this is the road which it is negotiating. And so there are two ways in which friction can act. Number one, like the car is going in the forward direction, so friction will be acting in the backward direction, which will be rolling friction in this case. But we are not interested in this friction. We are interested in this friction, in this manner, which is radial. So what is happening is this car is moving in this direction. This is the velocity. So there is you are turning your steering, the wheels are turned. There is a possibility that the car will be undergoing drifts, or it will be undergoing skidding or slipping on the road, so that even when the car like wheels are turned, even then the turning is not taking place, but the car keeps on moving in a straight line. That is a possibility. You might have watched the movies Tokyo Drift, or you might have watched Fast and Furious. And if you are the one who says that I have not watched these videos or these movies, how are you going to learn physics? You must watch those videos. Anyways, so this, what is happening here now? So friction is acting in the radial manner. Okay, now this friction which is acting here inwards is providing you with the centripetal force. There is a force, the car wants to skid in the opposite direction, but it is not skidding. There is no drifting taking place, just like Tokyo drift. This is not happening here. So this is moving like this now. Now what happens? Friction is like limiting friction, which is Fs max. It will be mu s into n, which will be mu s into m into g. I can show the forces in this diagram. This is the weight, this is the normal force, and this is the friction, Fs max. And the car is turning towards left only, okay, in this diagram. So this is it, and according to our condition, the friction should be equal to centripetal. So it is mu s mg is equal to mv square by r. M and m gets cancelled out. From there we can find the velocity, which is mu s gr square root. Now, mathematically speaking, this thing is not important for IB physics. The important thing is to understand what is happening. You can just have an idea about it. If you are not remembering these formulas, even then there is no harm. But you must know what is happening. There have been previous questions I've seen, like previous year questions. They do talk about the banking of the roads. They do talk about friction becoming the centripetal force, but they are not uh, doing this topic banking of roads in details, but they're asking you questions. So that is why I thought of giving you the complete topic itself. Okay, so this is the velocity with which the turning should be negotiated. This is the max velocity with which the car should be moving if you want to have this radius of turning with this much coefficient of friction between the tires and the roads. If this is the case, you could be negotiating a turn with the maximum of the velocity. Okay, now, point to be noted is that this velocity with which you can do this is directly proportional to the coefficient of static friction. So more is the friction, more will become the suitable velocity with which you can move. More will be the velocity with which you're moving. So more is the coefficient of friction, better you are at turning. But there might be chances that the friction is not sufficient. There might be chances that you need to negotiate the turn in a very small radius of turning. There might be a possibility that you are not able to reduce your velocity before you want to make a turning. What in those kind of cases? Because practically speaking, these kind of things do happen on roads. So we people come up with another kind of a phenomena which is called the banking of the road. And in this banking of the roads, what we do, we turn the roads like this. So the road is not flat now, it is inclined, and the car is literally like this. The car is literally like this. So if car is literally like this, what to do now? Let us see. So we are not going for this diagram here. So don't be concerned here. Only the road you have to see. So that you have to see this diagram that I am drawing. Now what is happening? This is theta, which is called angle of banking. And give me some time. Yeah, this is theta. So this is the mg. Wait. This is the normal reaction here. And we are not considering friction. So the point number 2 is no friction and only banking. And after that, I will do one more case in which we would be considering friction also. Beware, mathematics is not important, only and only understanding. Now, what is happening here and how the banking facilitates the turning, let me tell you. This is mg now. So this normal reaction can be divided into components here. This angle will be equal to the banking angle theta. So the normal reaction is creating two components, n cos theta, this is n sine theta. So n sine theta is going in a horizontal manner. We are interested in resolving all the forces in vertical and the horizontal direction. That is what we are doing. So weight is already vertical, so that is why I'm not disturbing weight. But the normal reaction is at angle. It will be better if I create the components for the normal. This is what I've done. Clearly, the normal reaction n cos theta is equal to mg, and n sine theta is providing the centripetal force, which is mv square by r. Or you can also bring in the concept of centrifugal if you understand that. So there will be a force equal and opposite, which is centrifugal, but that is not, as you might remember, I told you in my earlier videos, centrifugal forces are like they're not treated authentic by IB, so we can skip that. So n sine theta is equal to mv square by r. From here, I am interested in theta, so I divide these two equations to find tangent theta. So I divide these two. So when you divide these two, you would be getting somewhat like this. This becomes tangent theta, which is v square by gr, which means that the velocity with which you can negotiate the turn now, that will be given by gr tangent theta square root. So this is the reason that banking of the road is done. It means that the car can now negotiate the turn even if the driver is snoozing and he's not even moving the steering wheel. Even then, the turn will be negotiated and car will uh, uh, turn according to the road or according to the infrastructure. Yes, so this is done in the hilly areas, like to facilitate turning of the vehicle. Like you will not be needing to turn your weight to turn your steering too much. The turning can take place by itself. So v is equal to square root of gr tan theta. This is the maximum velocity depending upon theta with which the turn can be negotiated, even if there is no friction at all, even if you are not even turning your steering wheel. Okay, this is the essence of banking of roads. So now this is it. And in this case, we can clearly see more is the angle theta, more will be the velocity, suitable velocity with which you can negotiate the turn. So these are directly proportional. Now, so this is the third case when banking is there and friction is also there. So I will write friction and banking. Both are present. So let me draw the diagram here. This is the inclined plane, and this is our vehicle. Yes. This is the angle theta, the angle of banking. This is the weight downward, mg. This is the normal reaction here, and this should be the friction which is acting between the tires and the road. So these are the three real forces which are actually acting on the vehicle now. So now what we want is we want to create the components of the various forces only in the vertical and in the horizontal. So this is a vertical direction, this is horizontal. So now what happens? This angle theta is equal to this angle theta, corresponding angles. This angle theta is equal to this angle theta. That can be easily proved by using 90 degrees. Like this angle is 90 and this is 90. This is common. So these two angles are equal. So these are both of them are thetas. Now I'm going to create the components here. So how to create components? The normal reaction is creating components like this. And like this. So this is n cos theta and this is n sine theta. Now this is friction, and we can create the components for the friction also. So this is theta. So we can say there will be this force and there will be a downward force too. So this force will become F cos theta. This will be F sine theta. This is it. Again, telling you that the mathematics is not important for IB physics. Only understanding is important. There is one question completely based on this thing, whether the angle should be bigger or whether the angle should be smaller. Students are not able to understand things without mathematics. So there has to be a context. That is why I'm giving you this much of the mathematics. Otherwise, it's not required. You can skip learning. Okay. Now, the centripetal force is provided by these two. So these two forces are providing the centripetal force. So let's see. So it will be that the centripetal force is provided by n sine theta plus f cos theta, and also the vertical forces should be equal to each other. So I can write it as n cos theta is equal to mg plus f sine theta, isn't it? So these are just like equilibrium of forces. I have equated all the forces there so that the vehicle keeps on moving with a constant velocity. That's it. So this is the mathematical part. Now, what is the thing that is important for IB? The thing important for IB is that who is providing you the centripetal force. So centripetal force is dependent on theta as well as it is dependent on friction. So more is the theta, more becomes the centripetal force, and more is the more is the friction or the coefficient of friction, more becomes the centripetal force. So that these two factors, they will facilitate the turning of the vehicle. That's it. This is important for IB point of view. Otherwise, mathematics is in front of you. If you want to learn, you can do this. Otherwise, you can just skip that part also. Just understanding is important. Okay, dear students, so this is Professor Varun. Thanks for watching the video. See you in the next video. All the best. Bye.